Hi everyone in Algebra 3. This is going to be your new material from lesson 65. And what we're doing today is we're going to be going over radicals and trigonometric equations, as well as graphs of logarithmic functions. So there's going to be a few steps that we need to write down to follow the radicals and trigonometric equations. So if you can write these down, this would be the most helpful for you. So when you're trying to solve for a radical in a trig equation, the first step is going to be to isolate your square root. Your next step is to square both sides to get rid of the square root. Then once you've done that, you're going to separate it into two equations. You're going to solve, and then you're going to have to check your answer. So this is the key piece, is that in the end, you do have to check your answer. So anytime it starts with the radical in your equation, you're going to have to check your answer. Okay, so we're going to actually do the example together. This is example 65.1. I'm going to do it with you, and then I'm going to have you guys try to do the one in the lesson on your own. So the first thing that we're going to do, if we're following our steps, is the first step is to isolate your square root. So the first thing that I'm going to do is I'm going to move the square root to the other side. This will give me sine x is equal to the square root of 1 minus sine squared x. So I've isolated my square root. Step 2 is to square both sides. So I am going to square both sides of the equation. Now squaring the right side gets rid of the square root. Squaring the left-hand side gives me sine squared x equals 1 minus sine squared x. Now I have to simplify my equation, so I'm going to move the sine squared x to the other side by adding it. When you add two sine squareds together, you add the coefficients, so you get 2 sine squared x is equal to 1. Now, I'm trying to solve for sine, so I'm going to divide both sides by 2. So I get sine squared x is equal to 1/2. Then I'm going to take the square root of both sides. And don't forget that when you take the square root, you're going to get plus or minus 1 over the square root of 2. So now that we've done that, we've simplified our equation. Now we're on to step 3, which is to separate this into two separate equations. So I need to solve for sine x is equal to positive 1 over root 2, and then sine is equal to negative 1 over root 2. So I'm going to separate this into two separate equations. Okay. Now I have to determine in which two quadrants is sine going to give me a positive ratio. And then which two quadrants is going to give me a negative ratio. Well, all students tells me that everything is positive in quadrant 1 and sine is positive in quadrant 2. So that means if it's positive in quadrants 1 and 2, that means it's going to be negative in quadrants 3 and 4. So now I'm going to evaluate the degree. So this would be opposite is 1 hypotenuse is root 2. Opposite is 1 hypotenuse is root 2. That means my adjacent is going to be 1 and negative 1. So that means I know that these are going to be 45-degree triangles. In quadrant 1, it will just be 45, but in quadrant 2, I'd have to subtract 45 from 180, which would give me 135. Now for this triangle, I'm going to do opposite and hypotenuse. So opposite is negative 1, hypotenuse is root 2. Again, my adjacent side would be 1 and negative 1, and again, these would be a 45-degree triangle. In quadrant 3, you're going to add 45 to 180, which would give us 225. And in quadrant 3, I'm going to subtract, or 4, I'm going to subtract it from 360, which would be 315. Now what I have to do is I need to check my answer because that's the last step. So if you check one of the degrees in each of these, if it works for one, then it works for the other. If it doesn't work for one, then it doesn't work for the other. So you only have to check one of each, but unfortunately you do have to check, which makes it a little bit longer of a problem. So I'm actually going to go back to the beginning of the problem, and I'm going to start checking. So I'm going to start by plugging in 45. So sine of 45 minus 1 minus sine of 45 squared equals 0. So I'm going to show you how I'm going to do this in my calculator. So the sine of 45, I'm actually going to start in the parentheses, is 0.707. Then I'm going to square that because it's squared, and I'm going to subtract it from 1, which means that I have the sine of 45 minus the square root of 0.5. So I did the sine of 45, I squared it, then I subtracted from 1. Now I'm going to evaluate this. So 45 sine minus the square root of 0.5. And look, it equals 0. So the left does equal the right. Okay, so that's how I checked it. Now I'm going to try and check for this 225 degrees. So that would be sine of 225 minus the square root of 1 minus the sine of 225 squared equals 0. So again, I'm going to start inside the parentheses. So 225 sine, I'm going to square that. I'm going to subtract it from 1. And again, I get sine of 225 minus the square root of 0.5 equals 0. So now I'm going to plug this all into the calculator. So the sine of 25 minus the square root of 0.5 equals, and look, that's equal to negative 1.41, which does not equal 0. So therefore, my answers, x is equal to 45 and 135 work, but these do not. So these are not going to be part of your answer. Okay, so now what I want you to do is I want you to pause this video so that you can attempt number 9 on your own. And then when you're ready, we're going to check it together. So try this and then we're going to check it together. Okay, so for number 9, the first thing that I'm going to do is I'm going to isolate the square root. So I'm going to move the square root to the other side, and that would give me cosine x equals the square root of 1 minus cosine squared x. To get rid of the square root, I'm going to square both sides, which means the left side becomes cosine squared x. The right-hand side becomes 1 minus cosine squared x. Now I'm trying to solve for cosine x. So I'm going to move the cosine squared x to the left-hand side by adding it. And when you add 2 cosine squared x's, you're going to get 2 cosine squared x is equal to 1. Then you're going to divide both sides by 2. And you get cosine squared x is equal to 1/2. Then to get it, so it's just cosine, you have to square both sides, or square root both sides. Remembering that when you take the square root, you get plus or minus that value. So it'd be plus or minus 1 over root 2. Now I'm going to separate this into 2 separate equations. So I have cosine x is equal to positive 1 over root 2. And then I have cosine x is equal to negative 1 over root 2. Now I'm going to look to see in which 2 quadrants is cosine going to give me a positive ratio, and which 2 quadrants is cosine going to give me a negative ratio. So cosine is positive, or everything is positive in quadrant 1, and then cosine is positive in quadrant 4. So I'm going to draw two triangles in quadrants 1 and 4. If it's positive in 1 and 4, that means it's negative in 2 and 3. It's going to be adjacent over hypotenuse, adjacent over hypotenuse. So adjacent is 1, hypotenuse is root 2. And again, this is going to be a 45-degree triangle. So my answer is going to be x is equal to 45 for quadrant 1, and then 315 for quadrant 4. Now I'm going to label this triangle. Adjacent is -1, hypotenuse is root 2. This is also going to be a 45-degree triangle. In quadrant 2, you're going to do 180 minus 45, which would be 135. And then in quadrant 3, you're going to add it to 180, so that would be 225. But you're not done there. You do have to go back and check your answer. Anytime you start with a radical or square root inside the problem, you do have to check your answer. You do only have to check one in each of these sets, because then if one works, then the other one does. Also, if one doesn't, then it doesn't work for the other. So I'm going to solve by doing cosine of 45 minus the square root of 1 minus the cosine of 45 squared equals 0. So in the calculator, I do 45 cosine. I'm doing this part first. Then I'm going to square it. I'm going to make it negative and subtract it from 1. So I have cosine of 45 minus the square root of 0.5. Now I can do this all in the calculator. So it'd be 45 cosine minus 0.5, the square root of 0.5, and look, it's equal to 0. So the left is equal to 0, the right is equal to 0. So that means that these two do work. Now I need to check the other pair, which would be 135. So I'm going to do cosine of 135 minus the square root of 1 minus cosine of 135 squared, and check if that's equal to 0. So 135 cosine, I'm going to square it, make it negative, subtract it from 1. Again, I have cosine of 135 minus the square root of 0.5. And you can check this in the calculator. So it'd be 135 cosine minus the square root of 0.5. And again, that's equal to negative 1.41, which does not equal 0. So that means that these are not going to be one of my answers. And my only answers are 45 and 315. Okay, so the next one we're going to look at is going to be another example. So this can go in your notes. And this one we're going to solve in radians. So that means that in the end, our answer has to be in radians, not in degrees, which is something that's different than what you've been doing. So the first thing that we're going to do is this is already factored for us. So what we're going to do is we're going to set each of these equal to 0. So I have tangent x minus root 3 equals 0. I'm separating them into two separate equations. And sine x plus 1 is equal to 0. Now I'm going to move the root 3 to the other side. So I have tangent x equals root 3. And then sine x equals negative 1. Now I can always put my numerator over 1. And I need to identify, where is tangent going to be positive? We'll have all students take calculus. Everything is positive in quadrant 1, and then tangent is positive in quadrant 3. Label your sides as opposite over adjacent, opposite over adjacent. You should recognize that this would be a 60-degree angle. So for this one, we're going to have x is going to be equal to 60 and 240. But that's not your answer because again, you're gonna have to write this in to radians, so don't circle that. Now for this one, for where sine is equal to -1, that's not gonna be a reference triangle. We're gonna have to use our unit circle. And sine is equal to the y coordinate. So if I underline all my y coordinates, I'm finding what degree is sine equal to -1, or the y equal to -1. And that only point would be here at 270. Okay, but again, those are all in degrees and we want our answer to be in radians. Well, how do you do that? There's actually two ways you can do it. So one way would be to take all of your degrees and multiply it. So take your degree, x degree, and multiply it by pi over 180 degrees. Take your degree and multiply it by pi over 180. That's how you convert from degrees to radians. And you know that your answer has to be in radians because it says between 0 and 2 pi and not 0 and 360. The other way is to remember your snowflake drawing. So for 60 degrees, how many 60-degree angles can fit between 0 and 180? And the answer would be 3. So there would be a snowflake line here, here, and here, and then here, here, and here. Well, my first one is in quadrant 1. So you know that this is going to be over 3 because, again, 3 60-degree angles can fit between 0 and 180. So my first one away from 0 would be 1. So my first answer would just be pi over 3. My second one is in quadrant 3 here. So to count from 0, I go 0, 1, 2, 3, 4. And so my second answer would be 4 pi over 3. Now for this one, this is split from if you have arrows at all of your quadrants. So this would be 1, 2, 3, and here. And this would be your 0. So that means I split it into 2 equal measures from 0 to 180. So if I count to get to 270, I would go, sorry, this is over 2. Because it's 2 measures that I split it into between 0 and 180. So I would count 1, 2, 3, and that would be 3 pi over 2. And that would be your second answer. So this would be the other way to do it, would be to multiply your degrees by pi over 180. Now I want you to pause this video. I want you to attempt number 10 on this lesson. And then once you've attempted it, then I want you to do it with me or unpause it and make sure you did it correctly. So for number 10, the first thing that I'm going to do is I'm going to split these into 2 separate equations. So I get sine x minus root 3 over 2 equals 0, and then sine x plus 1/2 is equal to 0. I'm going to move both to the other side, so I get sine x equals positive root 3 over 2, and then sine x is equal to negative 1/2. Now I need to identify my 4 quadrants where sine is positive, where sine is negative. So all students take calculus. I know that it's positive in quadrant 1, and then again positive in quadrant 2. Because A is all and S is sine. Sine is opposite over hypotenuse, so this would be opposite root 3 hypotenuse 2, opposite root 3 hypotenuse 2. My adjacent will be 1 and negative 1. So again, those are going to be 60-degree angles. Now for the second one, I'm looking for where sine is negative. So I said if it's positive in quadrants 1 and 2, that means it's negative in quadrants 3 and 4. So it'd be opposite over hypotenuse, so negative 1 over 2, negative 1 over 2. My adjacent would be root 3 and negative root 3, meaning that these are going to be 30-degree angles. So now to write my answer, I'm gonna, again, so if you find the degrees, you can multiply your degrees, so x degrees times pi over 180 degrees. This converts it. But I want to practice this in radians, so I know that I can fit 3 60-degree measures between 0 and 180. So I'll go to 1, 2, 3, 1, 2, and 3. And I know I can fit 6 30-degree angles between 0 and 180. So 1, 2, 3, 4, 5, 6, 7, and then altogether there should be 12. But now I need to count for where the measures are. So this first one is in quadrant 1. So starting at 0, this would be 1. So that would be 1 pi over 3. My second one, if I'm counting away from 0, this would be 0, 1, 2. So this would be 2 pi over 3. So are my first two answers. The next one is going to be in quadrants 3 and 4. And starting at 0, this would be 1, 2, 3, 4, 5, 6, and my 30-degree angle would be at 7, and that would be 7 pi over 6. Now my last one is in quadrant 4, so 7 was my first one, then 8, 9, 10, and then 11. So my second one would be at 11 pi over 6. And that would be your result for both of those. Okay, so now we're moving on and we're going to be looking at the graphs of a logarithmic function. And what's changing about this is that this is what your old logarithm equation used to look like. It used to grow from left to right on up the y-axis, but this one's actually going to grow on the x-axis. And the reason that is because this is the equation, and if you were to convert this from logarithmic equation into exponential form, it would actually change to where the x and the y are. So what I'm going to show you is how to graph this function right here. Now, if I converted this from logarithmic form to exponential form, I have y equals log 3.5x. Now this is my base, this is my number, and this is my exponent. So if I convert it, it would be x is equal to base 3.5 to the power of y. So notice how that changes. It used to be y is equal to something to the power of x. And now when I graph this, I have x and y. So I want to find out where is this graph. We're going to be plugging in for y this time. So it's going to be, let's do -1, 0, and 1. So if I plug in -1 into this equation, it's going to flip this into 1 over 3.5. And I know that's not right, but it's about 1/3, oh, greater than 1/3. And then if I plug in 0, anything to the 0 power is 1, and then anything to the 1 power would be just that number, so 3.5. So you're plugging in for y values instead of x because then it would make it harder to solve for x. Now we're going to graph. So now you're going to graph, so this would be over 1/3 basically, and then down 1, then over 1 up 0, over 3.5 up 1. So notice that it's still an exponential function, it's just going to be on a different axis, and that would be your answer. So now what I want you to do is pause this video and I want you to attempt to do number 11 by yourself. So try number 11, and then once you've attempted it, then press unpause again. So for number 11, the first thing that you're going to do is you're going to convert this from logarithmic form to exponential form. So 2 is my base, x is my number, y is my exponent. So that means I have n equals b to the L. Again, when I make my X and my Y chart, you're plugging in values for Y this time because Y is on this side. You're solving for X. So I'm going to plug in the variables -1, 0, and 1. Now, if I have -1 in the exponent, 2 to the -1 would be equal to 1/2. 2 to the 0 would be 1. 2 to the 1 would just be 2. So when you're graphing this, it would be over 1/2 down 1, over 1 up 0, and then over 2 up 1. And this would be your graph of the logarithmic function. So it's just changing the axis that you're going to be drawing your exponential function. Now I want you to try numbers 12, 13, and 14, and then, and 15. And once you've attempted those, press unpause so that you can go through them with me. But these are from your latest lessons. So for number 12, for A, remember that your whole number is going to determine your left and right, and your I is going to be your up and down. And then you're converting this into the format of slant CIS of your angle. So since both this is positive and this is positive, 3 is telling me my left and my right, so it's going to the right 3, and then that's going up 5. So 3, 5, angle, hypotenuse. This is going to work the same way as it used to, so h squared is equal to 5 squared plus 3 squared. Pythagorean theorem, so 25 plus 9, h squared equals 34. So this would just be the square root of 34. Then to solve for your angle, this is your opposite side, this is your adjacent side. So you're going to use inverse tangent. So it'd be inverse tangent of opposite, which is 5, over adjacent, which is 3. In your calculator, it's going to be 5 divided by 3 equals, and then you do your second tangent. And that tells me my angle is going to be equal to 59.04 degrees. And again, you write your answer like this. It's your slant, so square root of 34, CIS, and then your angle, 59.04. So instead of that little angle marking, you're going to use CIS. And that would be your part A. Now part B, we have to convert 6 CIS 60 into rectangular form. So back into this format. If you don't remember, CIS stands for cosine plus I sine. So this is really just 6 times cosine of 60 plus I sine of 60. Now 60 degrees is a triangle in quadrant 1, where the adjacent is 1, the opposite is root 3, hypotenuse is 2. So when it says give an exact answer, they don't want you to use their calculator, they want you to use your reference triangle. So the cosine of this triangle of 60 degrees would be adjacent over hypotenuse. So it'd be 6 times 1/2. And the sine of 60 degrees would be opposite over hypotenuse, so that would be root 3 over 2i. And now you're going to distribute your 6, which gives you 3 plus 3 root 3i. So converting from polar to rectangular, I think is a lot easier just because it's kind of done in a couple steps. Okay, and that concludes number 12. Now, if you haven't tried number 13, I want you to do it first before you do it with me. So number 13, it says to multiply these two together and express the answer in rectangular form. That means you multiply the outside two numbers and you add the degrees. So when you do that, multiply 5 times 6, which is 30. Add the degrees would be 20 plus 70 is 90. Now we are going to have to expand this. So it'd be cosine of 90 plus I sine of 90. Now 90 degrees is going to use our unit circle at 0, 1. Cosine is equal to the x coordinate and sine is equal to the y coordinate. So the x coordinate at 90 degrees is 0. So this would be 30 times 0. And then the sine of 90 degrees would be the y coordinate, which is 1. So that would be 1i. So when you distribute the 30, you're just left with 30i is your result. So you multiply the slants and then you add the degrees and then you convert it and expand it from CIS to cosine plus I sine. Now moving on to number 14. So for number 14, we are going to be doing the same thing. And it says to give your answer an exact answer and then you multiply. So multiply again. So if you haven't tried this, I want you to do it on your own first before you actually do it with me. So you multiply the outside numbers, which would be 6 times 3, which is 18. And then CIS negative 30 plus 90 would be 60. When you expand this, CIS is going to stand for cosine plus I sine. So it would be cosine of 60 plus I sine of 60. My 60-degree triangles are going to be in quadrant 1, where the adjacent is 1, opposite is root 3, hypotenuse is 2. So the cosine of this triangle would be adjacent over hypotenuse, which is 1/2. The sine of this triangle would be opposite over hypotenuse, which would be root 3 over 2. Don't forget your I. And then when you distribute the 18, you get 9 plus 9 root 3i. And that's your result. If it does not say to write your answer in rectangular form, that means that you probably can't use your reference triangle. So therefore, you would not have to convert it and you would just leave your answer as is. So just make sure you're paying attention. And lastly, we're going to do number 15 together. So it says, write the equation x squared plus y squared plus 10x minus 75 equals 0 is the equation of a circle. Complete the square to change this equation to standard form. Find the radius and the coordinates of the center of the circle and then graph. So for number 15, the first thing that you want to do is put your x's together in parentheses and put your y's together in parentheses. And move the 75 to the other side. Now we're going to complete the square. So half of 10 would give me 5. When I square that, I get 25. And remember, whatever I do to the left side, I have to do to the right side. Half of 0 is just 0. So that would be y minus 0. Add 0, add 0 to both sides. 75 plus 25 is 100. Now the coordinate for the center of the circle is going to be opposite of what we're given. So the opposite of positive 5 would be negative 5. The opposite of 0 is just 0. So the coordinate of the center is negative 5, 0. The radius of the circle is the square root of the right-hand side, which would just be 10. So this circle is going to be very large. So 1. Well, I'm not going to finish it. So your coordinate of the center of the circle would be negative 5, 0. So 1, 2, 3, 4, 5. Your radius is 10. So 1, 2, 3, 4, 5. 6. doesn't even fit. So go 10 to the right, then 10 down. I'm not going to really complete my circle, so it's going to look something like this. Yeah, that looks horrible. Okay, so my radius right here is 10, and the coordinate for my center of the circle is -5, 0. So if you draw your circle a little better than mine, that'd be great. But if not, that's your problem. And that concludes your new material from this lesson. I hope you guys all have a great day and a great Easter vacation. Bye.